For today, we're talking about graphing things that aren't just like y equals x plus 2. That's a little too easy. You start at 2 as the y-intercept, and then the slope here is 1. I want to remind you, you can put that 1 over 1, and this will be rise 1, run 1. So I know it's been a few days since we graphed, so maybe you forgot, but this would be pretty easy to graph. You'd start at 2, you'd put a dot there, and then you'd rise 1, run 1, rise 1, run 1, rise 1, run 1. That's pretty easy, right? But what if I said less than or equal to? The only difference is you shade underneath it. That's it. That's the only difference. If it says less than, you'd shade. Doesn't less than seem like underneath? Doesn't that seem like underneath versus greater than? Doesn't that seem like it's above? It feels logical to me, so that's it. You graph a line, and then you shade above it or below it. Okay? So what's the catch? Well, there really isn't a catch, except that what we eventually get to is graphing like two lines on the same thing, and then you might shade under that one and under this one, and then you got to look for where they overlap. Do you see the area that got double shaded was like right there? That's the place that got double shaded from the blue line and the red line. And then you end up getting this thing called the feasible region. Big fancy word, feasible. Do you get feasible means like we could do that? Like if somebody said, we're going to build a high school that's 4 stories tall. Is that feasible? Yeah, you could make a 4-story high school. No big deal. What if we said, we're going to make a high school that's 900 stories tall? That's not feasible. That's not really possible. Okay, so feasible is the feasible region. That's the areas that could work, because feasible means that could work. So feasible means anything in this area that got double shaded, all of those points are feasible. They are possible for both equations to work. But this point over here, that only works in one of the equations, so that isn't in the feasible region. So feasible basically means it works. So if I gave you an xy axis and I said graph this thing, and you were able to go, oh yeah, here's my slope, here's my y-intercept, and then you got to decide to shade above or below it. What does less than mean? Below it. What would greater than mean? Above it. Okay. Now the one exception to that, of course, is if there's a line that goes exactly straight up and down. Then how the heck are you going to be below it? You can't be. So if I want below this line, then I actually want the smaller numbers. Does your gut say we should go left or right if we want below it, which means smaller than it? I've heard some people say left, some people say right. I think more people said left. It is left. That's smaller than it. Because, see, that's the only line you can't shade under or over. Every other line, you can either shade under it or over it. But a vertical line, then you have to pick which one is under that, and it's this way. This is under because why? Because the negative numbers are over there on the left side of it. All the negatives are over here, so this is under that line. Okay, and then the last thing is about dotted lines. Obviously, you can tell if I do this versus I do this, they mean different things. Okay, the dotted line means that it's gonna be just like y is less than a number. Then it'll be a dotted line. If it's y equals less than or equal to, then you get a solid line. So don't worry about this part. I'm not trying to actually say what they are equal to here. I'm just saying if you have an or equal to, you get a solid line. If you just have a less than or just a greater than, then it's a dotted line. So those are the key little elements. So if I just say less than, dotted or solid line? Dotted. If I say less than or equal to, solid. If I say it's greater than, which way am I going to shade? Greater than it, above it. Greater than it means above it, and if it's less than it, it means below it. And some people still have trouble with which one that is. Is that a less than sign, or is that a greater than sign? And you might be like, but it depends on the numbers around it. No, it doesn't. That's a sign. It's either the less than sign or it's the greater than sign. Which one is it? That is a less than sign. And I'll give you this hint. It looks like an L. So it's the less than sign. Does this look like an L at all? No. The less than sign looks like an L. The other one's the greater than sign. Okay? It does help if there's numbers around it, but it doesn't change the sign no matter what number you put where. Okay, if I put A and I put like 10 here, that reads A is less than 10. This means N is greater than 8. Okay, so there's your less than and your greater than sign. If I say or equal to, then it gets a solid line. If it says greater, you shade above it. If it says less, you shade below it. And yay, we've pretty much covered it. So I'm going to pause for a second. Y is less than 2x minus 1. That's the first one, right? Okay, cool. So let's just graph it. Now, you've got to get used to graphing these without a calculator. I know some of you just like thought, oh, I'll just use the calculator. You can't do these on the calculator. The less than thing won't work. Okay? So we got to find some important spots like the y-intercept. This is the y-intercept. So everybody start at -1 and put a dot there. Right there, see? And then this slope right here is at 2, but I like to put it over 1 to tell me a rise and a run. So Mallory, how much rise and run should I do to get my next dot? Rise 2, and you run 1. I'm putting a dot right there. And now I'm going to do it again. I go up 2, and I go over 1. There we go. Now, should I use a solid line or a dotted line? Dotted line. And the last thing that I taught you was, do you do above it or below it? And this one is a less than sign. It looks like an L. It's a less than. Should I shade below it or above it? Below. Less than means underneath it. That's the underneath side. Done. Don't be obsessed with shading every possible little corner of the graph. As long as you shade it on the right side of the line, even just a little bit, that's good enough. From my experience, if you actually make it shaded all the way to the edges, it gets actually more confusing than if you just shade a little bit on the one side. And now I just want to make sure, to be a good teacher, I really got to explain this last part. If you pick a number over here, let's say I pick a number that's at like 5, 3. What's special about all those things on that side of the line is that if I put them in, if I put the 5 in and I put the 3 in, it would read as a true statement. You know, the x was 5 and the y was 3. Is 3 less than 2 times 5 minus 1? Yeah, it is. 3 is less than 10 minus 1. 3 is less than 9. It reads as a true statement. If I were to take any other dot over here, like let's say at -1, 4, and I put those numbers in, it would not read as a true statement. You stick those numbers in, it will be telling you something that's false. Okay, so if I stick in x is -1 right here, and I stick in a 4 right here, it'll say that 4 is less than -1 minus 1, or sorry, -2 minus 1, which is -3. Is 4 really less than -3? No, it's not. So these don't work. That's the point. All of these dots over here work. When you stick them in, they make it a true statement. Every one of the dots on this side of the line. How about a dot that's right on the line? No, that's the point of a dotted line. The dots that are right on the line actually wouldn't work. They would be the place where it would equal the other one, but this says less than. Okay, so the ones that are on a dotted line don't work. If you ever get a solid line, those spots do work in the function. All right. I don't know if you had to know that last part, but I think some of the kids that are better at math will appreciate. All of these dots over here will make the equation true. Okay. So there's your first one. That was pretty easy. Avia, read me number 2.
So 3 plus y
Keep going.
is
it a less than because it looked like an L, or is it greater than?
greater than or equal to
Okay.
negative 1/2 x.
Okay. First pro tip. You want to get the y alone? To do any graphing, you got to get the y alone. So I'm going to start by subtracting 3 from both sides, but I wouldn't rewrite the whole thing. I just do what I just did there. Put a little -3 at the end and scratch this one out. There, I didn't have to go with a lot of extra work. Now, should I use a solid or a dotted line? Yes, this kind is solid. And now I got to make my line, and this is my slope. And this is my intercept. So I'm going to go find -3. Put a dot there. And then I'm going to rise -1. What the heck does that mean? Down 1. Very good. Down 1 over 2. So here's down 1, and then here's over 2. I'm going to put another dot. Down 1 over 2. And I really only have to do that once. Then I got my line. Why did I make it solid? Because it said or equal to. Now, which way should I shade? Above or below it? It said greater than, and that means above. That's all there is to it. You guys get it? Cool. Easy day. Okay. So easy, in fact, that I feel like we should do something else, but maybe it's okay. A lot of you guys took the PSAT today, so your probably brain's worn out from that anyway. So let's just have it be an easy day. And that's all I got. Unless there's a question. Yes, there's a question.
Yeah, can we do one of these problems?
Okay, read me one more that's different. Like number what?
Number 4, it's like
Okay, cool.
y
Y.
is less than or equal to x plus 6, and then under that is x plus y is greater than 6.
All right, good. Does it give you a graph where you're supposed to graph it?
Yes.
All right, so then we'll just do them as it's like 2 problems on one graph. So the first thing I'm going to do is make my XY chart, and then I'm going to start at 6 because that's the y-intercept. Put a dot there. And this doesn't have any numbers, but that means there's a 1 and a 1. So I rise 1, I run 1, rise 1, run 1, rise 1, run 1. Solid line or dotted line? Solid, because it says or equal. Good. And then it says less than. I can tell because it looks like an L. So I'm shading under it. So that's just the same as before. So what does this deal with 2 of them? Well, they're going to make you put them on the same graph and see where they both overlap. Okay? So now I'm going to subtract x from both sides. Why are you doing that, server? Because I want the y alone. Y greater than negative x plus 6. Remember, for graphing, you always have to solve for y. So that's why I subtracted x. So now I got to graph this one. It starts at 6 also. Well, cool. We've already been there. It's right here. But this one has a negative 1 over 1. So it goes down 1 over 1, down 1 over 1, down 1 over 1, down 1. I think you get the idea. So is this a dotted or a solid? I think it's just a, is it solid? Is it or equal to, or is it just greater than? It's just a dotted one. It's just a greater than. It does only solid if there's an or equal to sign. And I don't think there is unless somebody read it wrong. So then it's a dotted line that goes through it. And then the last decision is, which way should I shade? Avia, is that a greater or a less than sign? Right here. Is that a greater or a less than? It's greater. So I shade which way? above, up. Now, can you see where it got double shaded? That's what's called the feasible region. Right there, that's where it got double shaded. That's the extra special spots. Those dots that are in that area would work in both equations. They would make both equations true. That's the place where it got double shaded. Okay. You get how it was just like doing two of them on the same graph? That's all it really was. It was just like do two problems on one graph and see where they overlap each other. All right. So we got about 8 minutes-ish before lunch, and then after lunch you guys can keep asking me questions. Just try to finish this puppy up and drop it in the Dropbox. And then that's all we got for today.